The waves are generated with zero initial phase by respect to source. This is the one background we are assuming. Okay, now the waves, when they arrive, reach point P by covering different path. The waves reach point P by covering different path. They will have phase difference due to difference in path length. Okay, what is that? Delta phi is equal to the phase. So 2 pi lambda. Shall I write delta x? What is delta x? 2 pi lambda. So shall I write here S1p minus S2p? This is very important. Almost every problem, this is what I'll be thinking. So what do you mean by delta x? This will cover 5 meter, this 4 meter. What is it path length difference? 5 meter minus 4 meter, 1 meter. This will cover more path, so this will gain more phase. So because of path length, there's the phase difference. Okay, got this one. I'm interested. I let me stand here. I am here. I'm standing here. These are two sound waves now. So let's talk about what will happen to the intensity of sound signal. How to calculate intensity? We know intensity is directly proportional to square of amplitude. Can we calculate amplitude of waves arriving at point P? Yes, so first we'll go for the superposition. Y is equal to y1 plus y2. So a sine omega t minus kx plus phi plus a sine a1, let it be of different amplitude. Later on we'll change it. Kx plus. What is phi? There's the phase difference of the waves arriving at point P. At point P. In fact, they're generated with a zero phase. Why do this? Both are generated with a zero phase. Am I right? But by the time at point P, the waves arrive, this will acquire some phase. And better, what is the phase now? What shall I call? There's a phase difference between them. If I assume this to be zero, this will have a phase phi. Got this idea? Don't think that this will not gain any phase. This will also gain phase. This will also gain phase. The phase difference is what I'm writing. That's what here. I'm standing at point P. So this is something, let me define this as x equal to 0. Let point B at x equal to 0. So therefore, then what do we get? A1 sine. I think I'll magnify it. Huh? Yeah. A1 sine A1 sine omega t plus phi plus A2 sine omega t, that one. So I want the resultant amplitude. So the general solution of this will be AR sine omega t plus alpha. Later on we define. So I'm interested in this resultant amplitude. So what is AR equal to? This is some sort of like a vector addition. AR square equal to A1 square plus A2 square 2A1 A2 cos phi. Is it okay? Vector addition. R square equal to A square plus B square 2AB cos theta. What is the angle between A1 and A2? It's similar to that one. Phase angle phi, that one. How intensity? Intensity is directly proportional to square of amplitude. Can you remember this? So therefore, this will become resultant intensity IR equal to I1 plus I2 2 root I1 I2 so therefore finally what is IR is equal to I1 plus I2 so what is this IR resultant intensity at point P. So the person standing at point P, what is the intensity of sound signal is going to hear? So will you say that he will hear only due to this? These are what are S1, S2? Say loudspeaker 2. Better for your convenient purpose. So if he stands at point P, will he hear only sound signal due to loudspeaker 2 or only due to one? No, due to both. No, due to both the loudspeakers, what happen is going to hear the sound signal. So now then definitely what happen? What do he hear? He will hear the resultant intensity. And how much that intensity of sound signal which the person standing at point P is going to hear is given by this formula. No, he will switch off S1. He will switch off S2. Then he is going to hear a sound signal of intensity only I1. He will switch off S1. Then he'll switch on S2. Then he is going to hear the sound signal of only intensity I2. When he switch on both, then he's going to hear a sound signal that is given by this particular formula. What is this? This depends on what? This depends upon the path length or the path difference between the waves arriving at point P. Got the idea? So this is the main thing. So what is that phi? This phi is what? I should write it as 2 pi by lambda into delta x. So what is this? Already I have written this delta x is what I'll call path difference. This is the phase difference. Okay, let me go for some very interesting aspect here. So let's assume that let cos phi, the phase difference can be such that if delta x equal to can take any value. No, it's not that it should have specific value. Now let's ask question like, when you will hear maximum intensity, when cos phi equal to 1, when cos phi equal to 1, then IR will be maximum. Constructive interference, this one. For IR to be maximum, what is the condition? Cos phi should be equal to +1. For cos phi to be +1, what should be the phase angle? Shall we write 2n pi? The phase angle, this should be equal to, for cos phi to be +1, this angle should be equal to 2n pi. What is value of n? N is equal to, and so on. So then, so this should be equal to, what is this? I'll substitute this in this formula, 2n pi lambda equal. So what is delta x equal to n lambda? So what should be the path difference between two waves so that is going to hear maximum sound, or that is what we call constructive interference. The path difference should be equal to n lambda. So based on this, so what are the possible values of delta x? 0, lambda, 2 lambda, 3 lambda, 4 lambda, and so on. Then what is the expression for maximum intensity? Is equal to cos phi equal to 1. If you write it, this will be I1 okay, agreed. Am I right? The maximum intensity, how much it will be? Root of I1 plus I2 whole square it will be. These are conditions. If specifically I1 equal to I2, let the intensity of sound signal at point P, let it be equal. So let I1 equal to I2 equal to say I0. In that case, how much maximum intensity will be? So shall we put 4I0? So for constructive interference to occur, what is the necessary condition? The path difference of the waves arriving at point P, the path difference of the waves arriving at point P should be equal to n lambda. Then I'm going to hear a maximum intensity called as 4I naught. Okay, that particular condition is called as a constructive interference. Next, similarly, we'll go for destructive interference. Phi IR to be minimum. Cos phi should be equal to -1. Cos phi to be -1, what should be the values of phi? 2n minus pi, I'll write it. 2n minus 1 pi, that one. So then what are the values of n? N 1, 2, 3, and 4, so on. Okay, then this will be, if I substitute this, 2n minus 1 pi equal to 2 pi by lambda into delta x. The path difference between the waves arriving at point P should be equal to 2n minus 1 lambda by 2. Put n is equal to how much? Put n is equal to 1, 2, 3, 4. So what are the path difference now? This should be equal to 3 lambda by 2. Okay, can I continue?
Yes, sir.
Yes, sir.
Okay, there's no electric power. Huh? No. So there should be further simplification of this, how much it will become. Minimum, this should be equal to root of I1 minus I2 whole square. If I1 equal to I2, then if I1 equal to 2, what is the minimum intensity? Will be 0. This will be more, you can say. No, if I1 equal to, I wrote in black color, no, same thing. Yeah. If I1 equal to I2 is equal to, let it be I naught. Then what is be I minimum? Will be 0. Okay, this is a theory, like this. Okay, fine. Sir, how you can make I1 equal to I2? I can adjust the power of a source here, no? I'll show complete page. There's a one, you can say the theory is over. The story got over. Now we have to take help of this story to solve different types of numerical. I'll summarize everything and we'll see that what we can learn from this discussion. Okay, we have this much here. Okay, look at carefully now. There are two sources are there. Let intensity be I naught and I naught. Sir, but how come same intensity? Because the intensity depends also distance. Can I make power of source 1 more than that of 2? So that the intensity at this point will be I naught due to each source. Go back some basic small ideas, nothing big. The power of this source, let it be more than this one. Let it be more than that of the source S2. So there's a power of this source be P1, this is P2, let's say that. Then the distance are such that the intensity at point P due to individual source will be equal to I naught. Okay, fine, agreed. Okay, first I will switch off S2. Only S1 is on. Okay, let's do some. I'll take this diagram.